Alright, today in this video we're going to be talking about proportions, and specifically things that are directly proportional or have direct variation. And we've already spoken about direct variation in that it's a relationship where you're comparing x and y, and the way you find out what y is you take x and you multiply it by k, which I'll write in cursive here. So k is the special term that x is multiplied by in order to find y. So for example, if x is the number of t-shirts you're going to buy, then k is the cost of one t-shirt, the unit cost. So say a t-shirt's $5. So if x is 1, you're going to buy one t-shirt. 1 times 5 is 5, so you're going to end up paying $5. If you buy two t-shirts, 2 times $5 is 10. You spend $10 on two t-shirts. If you buy 3 t-shirts, 3 times 5 is 15. So the number of t-shirts you buy and the amount that you pay for them are very related to each other. They're predictable based on whatever this k is here, this unit cost. And so this is a special relationship that's called direct variation or directly proportional. And in this case, we are given one of the points. I always love to write x and y, x comma y, above these numbers. It's just always really helpful so you can remember which is which, because it's really easy to mix up the two and then get the problem wrong. But here it says if the points below do represent a direct variation. So we can't always assume that, but we can now because the directions say so. Then find the missing value. So you see the missing value here, x is the unknown missing value, so they want us to find what this x is. Here it's this y that's missing, or here this y is missing, here this x is missing, so that's what we want to find. It doesn't necessarily say to find what this k is, this constant of proportionality, but we could, maybe. Mostly what we want to find is this x, though. So I'm going to look and say, what is this x being multiplied by to get y? What is 5 being multiplied by to get 14? There's not an obvious answer for that. So it's somewhere between 2 and 3. 5 times 2 is 10. 5 times 3 is 15. So something kind of close to 3. We could go ahead and calculate it, but I'm going to go to a different method of looking at this. I can see that this y is now being doubled to get to this y. It's being multiplied by 2. And because these are directly proportional to each other, if the y is doubling, then I know the x has to also double. So 5 doubled is 10. So this x must be 10. I'm going to write that a little clearly here. X is 10. Now let's try another method. If we didn't want to use that method there, then another way I could look at this is to say, well, I know that k is equal to y over x, not x over y. And I know that it has to be the same k for both of these. So this y over x is 14 over 5. So that must be what k is. But that's also equal to this y over this x, this 28 over x. So here I have two proportions, two fractions that are equal to each other. And there's a couple of different ways I could solve this. I could do my cross multiplication, say 5 times 28 is the same as 14 times x. And I could multiply these numbers. I mean, this is going to get pretty big here. This is already looking a little more complicated than this, but let's see, 5 28s is the same as 10 14s, which is the same as 140, and that's equal to 14x. So if I divide both sides by 14, then I get x equals 10. So same answer, just a different way of solving. Let's see, another way I could look at it. Oh, so here I know exactly what k is. K is 14 over 15. So then I could always plug that back into my formula. I know, where am I going to write this? I know that y equals kx. So I know that y, which in this case is 28, is equal to k, which is 14 over 5, times x, which we're just going to leave as x. So now, in order to solve this equation, I can multiply both sides by the reciprocal. And this becomes a little easier because now I can kind of cross-cancel. This divided by 14 is 1. This divided by 14 is 2. And 5 times 2 is 10. These are going to cancel out. So I end up getting 10 is equal to x. So there's a number of different ways. I could also graph this. I could say this point is 5, 14, which is about here. And I know it goes through the origin because it's directly proportional. And so now it's asking me what x has to be in order for y to be all the way up to 28, which would be right about here. Instead of 14, it's going to be up to 28, which is double. So I know that instead of 5, it's going to have to be over at 10, which is double. And that's going to be where that point is there. This is just a rough sketch, but it kind of validates my method up here. I'm going to go ahead and do the rest of these on this note sheet here and see if they're helpful. For this one, I'm going to go and think, what is x being multiplied by to find y? And whatever that thing is, it's going to be constant. That's our constant of proportionality. So here, actually, this is pretty easy for me to see. What is 2 being multiplied by to get negative 6? Well, it's being multiplied by a negative, because a positive times a negative is going to be that negative. And it's going to be a 3, because 2 times 3 is 6. So if x is being multiplied by negative 3 here, this is going to be k, then this x would also has to have the same k. So 5 times a negative 3 is negative 15. That means this number right in here must be negative 15. I'm going to write it more clearly. Y is negative 15. Or you could use an equal sign for is. It's the same thing. Y equals negative 15. That is our answer. I found the missing value of y. Now note this is different from k because k was negative 3 here, but what it's asking for is y. That was simple enough, but another way to do it, would there be another way? Oh yeah, it's just k is equal to y over x. So this y over x is negative 6 over 2, but this y over x is y over 5. So focusing just in on these guys here, I can simplify this as negative 3 equals y over 5. And then I can multiply both sides of the equation by 5 in order to isolate y and find out what it is. Okay, y is all by itself, yay. What is it equal to on the other side? Negative 15. So same answer. Or you could cross multiply. You could do 5 times negative 6 is equal to 2 times y, which would be negative 30 equals 2y. And to isolate y, we're going to divide by 2. We get y is negative 15. So there's a whole bunch of different ways to get this answer. And whatever works best for you is just fine. You really only need to do it one way unless you want to be super sure you're getting it right. Then you can do it 2 different ways and make sure you get the same answer. Alright, here I'm going to look at the pair that's totally filled in because I don't know about this pair yet, this ordered pair. So here, what is 18, negative 18 being multiplied by to get to 12? Oh my gosh, that's going to be a fraction that's less than 1, but I don't know exactly, so I'm going to do a different method. I'm not going to figure out what this k is and apply it there. Instead, I'm going to do this method. I'm going to look at my two x's. Oh, I see a relationship here between my two x's. I can see that negative 3 times 6 is negative 18. So if my x is becoming 6 times as big, then my y also needs to become 6 times as big. This is not a decimal, this is a multiplication symbol of a dot. So what would y be such that when I multiplied it by 6 I'd get 12? It must be 2. I really like that. That's kind of what I'm calling a little bit of common sense reasoning here. It's not the best title, but or if we really want to do the proportions, we could say y over x is equal to y over negative 3. This is what our k is, right? And then this y over x, I didn't write it above, but is 12 over negative 18. I can cross multiply here. Let's see. I can what else I could do. I can multiply both sides by negative 18. And I end up getting 12 equals, let's see, this divided by negative 3 is 1, this divided by negative 3 is 6. So I get 6 times y over 1 is equal to 12, and y is equal to 2. Same answer, either way. I'm just going to do one solution going forward. Let's see, I'm going to look at my ordered pair that's totally filled in. I don't know what 12 times what is negative 27, so instead of figuring out k, I'm going to compare my y's. I'm noticing that 9 times a negative 3 is going to get me to negative 27. So what times a negative 3 is going to give me 12? Here's another way to write it. X times a negative 3 is going to give me 12. Well, I can figure out that this must be a negative 4, or I can literally just divide both sides by negative 3 and get x equals negative 4. I found that missing value. 2 more. These ones are a little bit funky. I really like it when two ordered pairs are written next to each other, so I'm going to do some translating here. I'm going to turn this into two ordered pairs. Find y, so it's always xy, xy. Find y, okay, that's what I'm finding. I don't know what it is yet. When x is 14, okay? If y is negative 3 when x is 6. So, I can figure out what k is. I know that x is being multiplied by, let's see, positive to negative. It must be something negative. And it's being multiplied by a half, because a half of 6 is 3. So if that is being multiplied by a negative 1/2, then this is going to have to be multiplied by a negative 1/2. And a negative 1/2 times 14, or a negative half of 14, is negative 7. So that must be what my y is, negative 7. And this is my k. Lastly, let's do the translating again. Find x, okay, when y is negative 12. If y equals 4, again, don't write 4 first. It's always x comma y. So if y equals 4, when x is 3. You see that? Don't write 4 comma 3 here. That would be an easy mistake. So it's not immediately obvious to me what 3 is multiplied by to get 4, so instead of that, I'm going to compare these two y's. And I'm going to see that this times a negative 1/3 is that. Let's actually go in the other direction. This times negative 3 is negative 12. So this times negative 3 is negative 9.